Problem number one, solving for the area under the curve. The problem is solve the net area of region S that lies under the curve of the function x squared and above the x-axis from 0 to 1. So I already sketched the graph of the parabola, and this is our f of x. So f of x is equal to x squared, and the curve above the x-axis. So this is our x-axis from 0 to 1. So it will start from here until here. So this will be our boundary, okay, or the limit, something like this. So the area that we're talking about is this, the region bounded by the curve and above the x-axis from 0 to 1. So this is our area. All right. Now, for us to do that, for us to get the area, let's identify the rectangular strip. Okay. And this is the rectangular strip that we will be using. All right, something like that. And let's use another color, a blue one. And let's get to this area, to this point. This is our x of I. All right, and the length of this rectangle is change of x. So this point is what we call the point x sub I and the f of x sub I. Okay, so I hope you can read the point x sub I and f of x sub I. So for us to determine the area, we can use the Riemann sum, so which says that the area is equal to the summation of the function f of x of I times the its with change of x, and we get its limit where change of x approaches infinity, and the sum of this is at I is equal to 1 up to n. So this is the representation of the area of this shaded region. This one, the shaded region. So in this case, we can convert this into an integral expression, and this is equivalent to of f of x dx from 0 to 1, since it is bounded, or the region is bounded from 0 to 1. Okay, so let's substitute the value of the function. This is equal to, let's use blue. This becomes the definite integral of x squared dx from 0 to 1. So the first thing that we need to do is to integrate x squared. So that's x cubed over 3 from evaluated from 0 to 1. So by definition of integral, by definition, using the fundamental theorem of calculus part 2, now this is equivalent to 1 cubed over 3 minus 0 cubed over 3, which is equal to 1 over 3. So that's why the area of this region bounded by the function f of x from 0 to 1 interval is equal to 1/3. So this is our final answer for this.